And what about this? Zero and four.
Minus 1 plus 2
Minus 1
plus 2
plus 2. 0.
plus minus 3 plus 1.
What's the meaning of 0? 0 means if you have the inputs, for example, for this system, I think it's better to record.
The memory.
Oh, the memory is full?
But the two operations not.
I think, for example, this is minus 2 and minus 3 is pole of the system. Yes, pole of the transfer function. This is the system. S plus 1, S plus 2, S plus 3. Yes? U. We set U as, for example, S plus 3. What about the output? The output is equal to S plus 1, S plus 2, S plus 3 multiplied by S plus 3. Yes? If these modes are equal, you cannot see this mode in the output. This means pole. And what about 0? If we apply 0 here, this is 0 of the system. Yes? The output of the system you cannot see this in output of the system. The transfer function deletes the mode like pole and 0 in output. Didn't let the mode, the pole, and the 0 that cross the transfer function. This meaning should apply for the MIMO. Let me check. For example, this is a 0. You said that minus 3 is 0. Yes? I put the input S minus 1, S plus 1, 1, 1, plus 3, S minus 2. Yes? This is the 0, yes? If we apply this, we should not see this in output. We multiply this. you see these items in output. This is not zero. This is not zero. This is not four. This is not four. The definition of zero and pole in SISO system is not valid for MIMO system. MIMO means multi-input, multi-output چند متغیره. In MIMO system, the definition for this system is not valid for. We should deliver you some definition for zero, pole, transfer function, designing controller, stability. The stability form, the stability theory for the SISO system is not valid for MIMO. Why? Because the zero and pole definition are different. Okay, in this lesson we want to discuss about these systems. This course really is easy. It's the easiest course in control engineering. If you study. In this course, we want to learn how to calculate the closed loop system, zero and pole of the multivariable system. We said MIMO system, multivariable system, is all of them are equal. Synthesis and analysis of the systems, the stability of the systems. Designing these two chapters discuss about designing controller for multivariable control. The Persian reference تحلیل و طراحی سیستم کنترلش همونطور دکتر خاکی صدیق is this is the famous professor in Iran in control engineering. لطفیزاده نه لطفیزاده no خاکی صدیق لطفیزاده work on a fuzzy system. Multivariable feedback design by John Masichowski or Addison Weasley. This is suitable for your reference. Okay? Only the name is hard, but the lesson is easy. Let's refer to the Can you write the transfer function from R to Y? Yes. This is SISO. Yes. Who's that? N? No, on the second line. Oh, U, N. I think you should write N. G? Yes. You should, yes, the transfer function, you should transfer y to the other side of equation. G, yes, equal to RG. Thank you. This whiteboard is very small. Y equal to equal, yeah, that's okay. No. R of R multiplied by G of, yes, yes. You can write here. Divide both sides of y of s over r of s. Yeah, thank you. This is for SISO systems. Okay, thank you. Means y to r equal to g over 1 plus g multiplied by c. Okay? Let me change the structure. And what about the closed loop of this system? Y to r equal to 1 c g c g for this. The next one. Okay, or not? This is side so means c of s, the dimension is 1 multiplied 1. G of s, the dimension is 1 multiplied 1. What about this? This is my way. G, the dimension of G, the dimension of G is L, M, the dimension of L is M, L. How we can find the closed loop system? Is it possible to write? Yes. It's MIMO. It's different from the above transfer function. I help you. Write like the previous. Let me write the dimension of y, L, 1, N, 1, L1 and R is L1. This is the dimension of this system. Right. Y equal to oh no.
This is what?
No, please, for example, you can write y equal to u multiplied by g. It's better.
Y equal to U multiply.
Y equal to
Okay.
only write for this, u for this.
Multiplied by U, and U is equal. Let's see of S.
Yeah. Oh, stop. What's the dimension of g?
The dimension of G L
L
multiplied by
L.
1.
and u.
U L multiplied by 1. So
L and N
L
1 is okay. E
L by 1.
L by 1. C
C M by L.
is right.
Okay.
This is the main difference between SARSO and MIMO. Okay? And the next one.
So can
E equal to
E equal to
R minus Y.
R minus Y.
For you or for me? Oh,
R is L must be the same dimensions, isn't it?
yes.
L1, Y,
Good. L1.
L1.
It's okay.
Right.
Yes. You should put U here. Y equal to E. Yes. E equal to R minus Y.
Yes. It's L.
Yes. You put E as here.
E.
No. Y equal to you can for simplicity delete this. G C R minus Y. Transfer all the y to the other side. Plus G C Y equal to G C R. Yes, that's okay. Take a factor from y. Well done. This right. I forgot your family. Madid, this is matrix. You cannot divide two matrices like this. Erase it. Nobody can. Nobody doesn't see. Try. Right? Parenthesis. Y. Right. I plus G C Y equal to G C R. Okay. Y equal to I, sorry, I plus GC inverse GCR. Okay? We cannot write like this. Why? This is vector, this is vector. We cannot divide two vector on. This is a transfer function. This is correct, and both of them is correct.
We replace the one factor by identity.
One, no. This is not, this is a vector. Yes, identity. Okay. Thank you. That's okay? This is very important. You don't have a problem. You don't have a mistake on investigation for the transfer function, because the transfer, if the transfer, you have a mistake on a transfer function, all of the problem you cannot solve it. Another thing in this system, C multiplied by G, the dimension is M, L, L, N. The dimension of this matrix is M, N. And GC is LM, LM, sorry, ML, this is LM. GC or not is not equal to CG. You should remember always, it's not equal. Maybe in one case, maybe it's equal, but in general, it's not valid. We can see that in SISO system, GSC multiplied by G is equal to G multiplied by G of C. Yes? This divided by 1 plus GCG. In SISO system, is it possible? It's possible. But in MIMO system, it's rank. It's a big rank. Okay? In MIMO system, GCG, we call this in this problem C. In this textbook, we read GC. GC multiplied by G is not equal to G multiplied by G of C. There are many representation for MIMO system. The first one is transfer function, which is easy to see. The second one is state variable that you learn in modern control. Yes? Oh, I see. The description being between the input of the system and output of the system, sorry. Input of the system and output of the system can be derived by transfer function. If we want to know about the state of the system, if we want to know inside of the system, we should refer to the, or we want to know internal description of the system, we should refer to the state variable. A state variable defined inside of the system. If you want to know inside of the system, you should refer to state variable. Sorry, I should answer the phone.
Your email just to send the folder. Just to send the folder.
Oh, okay. Thank you. Thank you. If we want to transform the state variable, the state space, to the transfer function, we can use this transfer function. X dot equal to a of x plus bu, y equal to cx plus du. The transfer function equal to c si minus a to the power of minus 1 b plus d. And if we want to transfer, if we want to find state space for the transfer function, there is infinity state space for transfer function. One transfer function can have one transfer function has infinity realization as a state space. One state space, one transfer function. One transfer function, infinity state space. We call this, the second one, as a realization. Finding state space for transfer function, we call it realization. In MIMO system and SISO system, if we want to find transfer function, see this. For example, consider G as a SISO system. Consider, for example, GP4. If input of the system is 2, the output becomes 8. 4 multiplied 2 becomes 8. Yes? Or consider G as 4, U as 2, Y becomes 8. If we have input and output, we divide outputs over inputs, we can find G. Always G is constant. In MIMO system, it's not constant. Why? Consider U1. The norm of U1 is equal to 1. What's a norm? Norm of U1 means 1 to the 1 to the power, like this. Yes? Norm of U is equal to U1 over u1 to the power of 2 plus u2 to the power of 2. The norm of u1 is 1. This means this is a point. The mouse, yes, this is the point u1. Okay? For example, u2, this is this point. Okay? Both of this, norm of u equal to 1. We put u1 in this equation, g equal to 5, 4, 3, 2, u1 equal to 1, 0. Yes? Y equal to 5, 3. 5 multiplied by 1, 4 multiplied by 0 become 5. 3 multiplied by 1, 2 multiplied by 0 become 3. If you want to find the gain of g, we divide norm of y1 over norm of u1. The norm of y1 equal to 5 to the power of 2, 3 to the power of 2, and the norm of u equal to 1. The norm of y1 is equal to 5.83, and the norm of g equal to 5.83, because the norm of u is equal to 1. Okay? This is for u1. And u2, y2 equal to 4, 2. Okay? We multiply g by u2. Okay? The norm of y2 equal to 4.47. And norm of g equal to 4.47. This is difference between two systems. Input change. Yes, we change the inputs. The transfer function is same, but the outputs are not same. The direction of input, y1 is this direction, y2 this direction. The direction of inputs impress the outputs, impress the effect on the output of the system. It's very important in MIMO. Based on your input and output, you cannot find the gain of system. In SISO system, if you have an input and output, you can find the transfer function. But in MIMO system, it's impossible. Because in addition of input and output, you should know the direction of inputs. Okay?
The output depends on the output depends on
The output divided by input only give you the gain of the system for that output, not for all the input. But in SISO system, when you say g equal to 4, g equal to 4, for u equal to 2, u equal to 3, 4, 6, 7, 8, for all inputs is okay for SISO system. But for MIMO system, it's not okay. Consider u3 as this. The norm of u3 is equal to 1. The norm of u4 is equal to 1. The norm of u5 is equal to 1. And y3, y5, y4, y3 change. Okay? And the norm of g changes for all the inputs. That's the norm of the input is equal to 1. The norm of the input equal to 1, but the norm of the g changes. Norm of the g show you the gain of the systems.